Hi, hello, good evening. Welcome back. This is Vanajakshivi, pursuing my education at Shaving Teshwara College of Engineering and wearing the SN 1V21 CS 184. Today I am here with the topic quicksort and its time complexity. First of all, we learn about what is quicksort. Quicksort is a highly efficient sorting technique that divides a large array data into smaller ones. A vast array is divided into two arrays, one containing the values smaller than the provided value. We say or we call it as a pivot points on which the partition is based. The other contains values greater than the pivot values. To understand better, here is an example of quicksort. We have the values arranged in an array like 19, 17, 15, 12, 16, 18, 4, 11 and 13. We are taking the pivot point, that is 13. The last value will be considered as a pivot point. Here in a quicksort we have two cases, less than or equals to 13, greater than or equals to 13. In an array, the less than or equals to 13, we have the values 7, 12, 4 and 11. In greater than or equals to 13, we have values 18, 15, 19 and 16. Similarly, in 7, 12, 4 and 11, we have less than or equals to 11 and greater than or equals to 11. Less than or equals to values are always placed on the left side and greater than or equals to values are always placed on the right side. Less than or equals to 7 from an array of 7, 12, 4 and 11 or 7 and 4. Greater than or equals to 11 or 12. Similarly, in 18, 15, 19 and 16, greater than or equals to 16 or 19 and 18. Similarly, less than or equals to 16 or 15. In the same way, in 7 and 4, 4 is less than or equals to 7. That's why it's been placed left side. Similarly, in 19 and 18, 18 is less than 19. That's why it's been placed at the left side. Here is an algorithm for quicksort. To understand better, I'll be telling stepwise. In step 1, we have to choose the highest index value as a pivot point. In step 2, take the two variables to point left and right and the list of executing the pivot. In step 3, left points to the low index. Step 4, right points to the high index. In step 5, while the value at left is less than the pivot, move it to the right. In step 6, while value at right is greater than equals to the pivot, move it to the left. In step 7, if both the step 5 and step 2 does not match, then move it left and right. Step 8, if left is less than equals to right, then the point where they meet is a new pivot point. The partition algorithm rearranges the subarrays in a place. Partition, array A, start and end, open braces. We have pivot, that is A and I, that is start minus 1. For J, we have start to end, that is minus 1. For do if A of J is less than pivot, then I we have I plus 1. We have to swap A of I with A of J. Then swap A of I plus J with A n and we return the value I plus 1. Time complexity of a quicksort. Quicksort is a sorting algorithm that works using a divide and conquer approach. It chooses a pivot and places it in a correct position in the sorted array and partitions the smaller elements to its left and greater ones to its right. This process is to be continued for the left and right parts. Also, the array is to be sorted. Here is a short algorithm like sort int a, int lb, int ub. If ib is less than or equals to ub, then return. If j is equals to partition a comma ib comma ub. We have the worst case and the best case that I'll be discussing it later. Sort a comma ib j minus 1, sort a comma j plus 1 comma ub. We have three cases, best case, worst case and average case. The best case occurs when we select a pivot as the mean. So here O of n into log n, that is T of n is equals to 2 into T into n by 2 plus n into constant. For the worst case we have O into n2, that is the worst case will occur when the array gets divided into two parts. One part containing of n minus 1 elements and the other and so on. For the average case, we consider the array and gets divided into two parts, that is size of k and n minus k. So we have O into n into log n. Best case complexity. In quicksort, the best case occurs when a pivot element is middle element or near to the middle element. The best case time complexity of quicksort is O into n into log n. Worst case complexity. This may occur if the pivot happens to be the smallest or largest element in the first list or in the same implementations. Example, a lumped partition scheme as described above. When all the equal elements are equal, so in the case of quicksort, it takes O into N2 time. Average case complexity. It occurs when array element is jumbled in order that is properly ascending and not properly descending. The average case of quick complexity will be 0 into n into log n. Before concluding, I am here telling about advantages and disadvantages of quicksort. The advantages of quicksort are fast and efficient. Quicksort is most favored user choices to perform the sorting functions quickly and efficiently. Cache friendly. The most talked feature about the quicksort is that it is cache friendly. Time complexity. The time complexity is the time taken by an algorithm to run in its completion. That we have best case time complexity, average case time complexity, and worst case time complexity. Space complexity. Quicksort has a space complexity of 0 log n, making it suitable algorithm when we have the restriction in a space availability. Now the disadvantages of quicksort. The disadvantages of quicksort are unstable. Quicksort is undoubtedly a faster and efficient sorting technique, but when it comes to a stability, you might have to reconsider your options. These sorting algorithms is regarded unstable as it does not retain the original order of the key value pair. Worst time complexity or worst case time complexity. In the above section, we saw that the worst complexity in detail. This is actually a drawback of a quicksort. It usually occurs when an element selected as the pivot is the largest or smallest element, or when all the elements are same. These are the advantages and disadvantages of the quicksort. I here conclude that quicksort is a method that sorts the element using a divide and conquer approach and an average as O n log n complexity. It will be implemented in the both recursive and iterative way. This is in place, cache friendly, and also a tail recursive algorithm. By this I conclude the topic quicksort. Thank you one and all.